Hello dear students, I welcome you all to the next edition of online class on coordinate geometry. Okay, so today's topic is various forms of equation of a line. Now before I begin with the various forms of equation of a line, let us see some basic equations which we need to know. Okay, so the first equation is equation of x-axis. Okay, so equation of x-axis is always written as y equals to 0. You need to remember this. All right, why we are writing y equals to 0? Let us try to understand. So basically here in this particular video we will just learn how we are getting all these equations. That's all we are going to learn. All right, fine. So as you know, this is my x-axis, this is my origin, and this is my y-axis, right? Okay, so we are interested in finding how the equation of this x-axis become y equals to 0. Now we always know that any point on the x-axis can be written as x comma 0. That is, the ordinate will always be equals to 0. And what is ordinate actually? Ordinate is the value for y, right? So if you take this point here, also ordinate is 0. Similarly here also the ordinate will be 0. So that's why the equation of x-axis is written as y equals to 0, because at every point on the x-axis the value of ordinate is 0. So this is the equation of x-axis. Okay, similarly the equation of y-axis will be x equals to 0. Now if you look at y-axis, you choose any point. So there you will find that abscissa will be equals to 0. Right? Similarly, if you take this point, here also the value for x will be 0. So that's why the equation of y-axis is taken as y equals to 0. Okay? So this is the equation of y-axis. Now let us see how the equation of line parallel to x-axis look. So there is, okay, so let me erase this part. So here we have got again x-axis and y-axis. So we are interested in finding equation of a line parallel to x-axis. So let me take a line which is parallel to x-axis, okay, and let us take the distance between this line and the x-axis to be a. All right. Now if you see here, any point on the line can be written as, okay, so it can be written as x comma a. Why? Because see, this distance is x. For example, from here to here is x. All right, and from here to here, what is the height? Height is a, right? So that's why I am writing my ordinate to be a. Similarly, if you choose this point, it can be any other point, right? X. For example, from here to here it will be x, and from here to here, what is the height? Height is a. So that's why again in this case also we have ordinate equals to a, right? So that's why the equation of line parallel to x-axis is written as y equals to a. And what is a? A is the distance of the line from x-axis. All right, so this is how we represent the equation of a line parallel to x-axis. Okay, and next we have equation of a line parallel to y-axis, and in this case my equation in the similar way is going to be x equals to a. Now what is a in this case? A is going to be the distance of the line from y-axis. All right, so you may pause the video to note down the basic equation. Okay, so having understood the basic equations, now let us move on to the main topic for the day, that is various forms of equation of a line. Okay, now before we go into the detailed explanation of this, let us try to understand what is equation of any curve. For example, if I have xy coordinate system, we call it rectangular coordinate Cartesian coordinate system as well. So let us consider this rectangular Cartesian coordinate system. Okay, now here I am drawing one random graph for you. So for example, this is my random graph. Okay, now if you see here, let me plot this coordinate. Okay, so something like x1, y1. All right, similarly let me choose this point, let me call this to be x2, y2. Similarly, let me choose this point, let me call this as x3, y3. So basically I have shown you only 3 points out here, but there are numerous points. For example, here also we have got 1 point, here also we have got 1 point, here also we have got 1 point. Similarly, all these points when I join them, then I am finding this particular curve, isn't it? So basically the equation of any curve means, okay, so in the equation of any curve we have two quantities involved. One is the x value, okay, and another is y value, okay, and the relationship between them, that is the relationship between x coordinate and y coordinate gives you the equation of that particular curve. You just need to remember. So if anybody asks you what do you mean by equation of any curve, then you have to say that equation of any curve is the relationship between the abscissa and ordinate for that particular curve. Alright, so that's what you need to say. Okay, so that's all about equation of any curve. Now let's go back to our work, that is equation of a line. So let me take a straight line in here. Okay, so I am taking a straight line here. Okay, and let me take, okay, so the first kind of equation is point slope form. So in this case you need to be given slope of the line, okay, and a point through which the line is passing. For example, let me take this line. Let me call the slope to be m, assuming that I know the slope, and let me take one more point through which the line passes, and that point I am taking this to be x1 y1. Okay, now the equation of such line, okay, whose slope is known and whose point, okay, the point through which the line passes is known, then the equation of such line is given as y minus y1 equals to m into x minus x1. So this is the equation in point slope form. Okay, so this is our first form. Now second form is 2-point form. Okay, so in this case we are not given any slope, so there are 2 points given through which the line passes. All right, so instead of this m, there is one more point is given through which the line is passing. Okay, so in this case the equation of line becomes this. Now if you see here carefully, okay, I'm sorry, this is y2 minus y1, this is x2 minus x1. Now if you see here carefully, what is this y2 minus y1 whole divided by x2 minus x1? This also gives you the slope of the line, isn't it? Right? So basically this equation and this equation both are equivalent. Only thing is here instead of slope we are writing point itself, right? x1 y1 and x2 y2. So this is the equation of line in 2-point form. Okay, fine. So next is slope intercept form. You have come across this kind of equation in your junior classes as well. Okay, so what is the meaning of this y equals to mx plus c? Now let's try to understand. So obviously as we can see m over there, so m stands for slope, right? Okay, so let me take this line, okay, and let me take the slope to be m. Okay, now let me take this height to be c. Okay, so this c is called y-intercept. Now what is the meaning of intercept? Intercept means at which distance from origin does the particular line cuts the coordinate axis. For example, this line is cutting at this distance in the y-axis, right? So that's why c is called y-intercept. Remember that c is y-intercept. All right, now for example, if you see here, the same line is cutting the x-axis at this distance, isn't it? So this distance is known as x-intercept. Okay, so this is c stands for y-intercept and this distance is called x-intercept. All right, so in this particular equation we are not going to include any x-intercept. Here we are going to include only two things, that is slope m, okay, and another is y-intercept, that is c. Okay, so that's why it is called slope intercept form. Okay, now the next equation is intercept form. Okay, so intercept form means there are no slope being seen out here, right? So we can see only a and b. Let us try to understand what is the meaning of this particular equation. So again, x-axis and y-axis, the same line. Okay, so from here to here we call it x-intercept, right? So from origin I am measuring the distance at which the line is cutting the x-axis. So this distance is called x-intercept, right? And here this A stands for x-intercept. Okay, so basically this is my A. Okay, and this B stands for your y-intercept. Okay, so this B stands for y-intercepts. So that's what is the meaning of this particular form, that is intercept form. Okay, so don't get confused. Here B and this C both means the same, all right? But since you are using in two different equations, and there you are making use of two different alphabets. For example, here you are using B for y-intercept and here you are using C for y-intercept, all right? But you need not get confused out here. Okay, so this is your intercept form. Now next is normal form. Here this particular equation is very, very important. How? Let us try to understand here. Okay, so equation of a line in normal form. So that's what we are going to learn here. So you need to pay attention here very, very carefully. Okay, so let me take again, this is my line. Okay, normal. Now all of you know that normal is nothing but perpendicular, isn't it? Okay, so basically to this line, to this particular blue line, I am going to draw a perpendicular. Okay, so from where? From origin, that I am going to draw a perpendicular. So this is my perpendicular, as you can see. So this sign means that this line is perpendicular to this particular blue line. Okay, and here let me assume that this particular line, this perpendicular, is making angle alpha with the positive direction of x-axis. Okay, and let me assume that this this distance from here to here is, let me call this to be P. So basically this P stands for the perpendicular distance from origin. Okay, this alpha stands for the angle made by this perpendicular line with the x-axis. Okay, now let us make use of this triangle. Okay, let me give it a name. For example, A, B, let me call this as C. Okay, so let's have a look at this particular triangle. Okay, so in triangle OBC. Okay, so whenever you have angle given to you, side opposite to angle is called perpendicular, right? And this is 90 degrees, so side opposite 90 degrees is called hypotenuse. So that means whatever is left, that is my base. Okay, so basically if you see here, what am I trying to find is, I am trying to find x-intercept, because this line is called, this distance is called x-intercept, right? And similarly I am going to find y-intercept as well. Okay, so we'll find x-intercept, we'll find y-intercept, and we'll make use of this intercept form, because A is x-intercept and B is y-intercept. We'll use this form to arrive at this form. Let's see how to do this. So as I said, in right angle triangle OBC, we have to find this, right, which is hypotenuse. So we have hypotenuse and what is this? Base given. So base and hypotenuse can be used to find what? To find cos, isn't it? Because the cos theta is curly brown hair, that is base by hypotenuse. So we have cos theta, and what is theta for me? Theta is alpha, right? So cos alpha is equals to base by hypotenuse, right? And what is base for me? Base is P, isn't it? So instead of this I am writing P. And what is hypotenuse? Hypotenuse is this distance, that is OB. Okay, so from here what is this? OB turns out to be P cos alpha. Okay, so this distance is P by cos alpha. Similarly, let's find this. So we can find this, isn't it? So let's see how to find this. Okay, now all of you know that this whole angle from here to here is how much? 90 degree, right? Now if this is my alpha, then how much is this going to be? This is going to be 90 minus alpha. Okay, so this angle is 90 minus alpha. Okay, so side opposite to angle is perpendicular. Again, this is also 90 degree if you see here. So basically I am talking about triangle ACO or OCA. Okay, so in triangle OCA, so if you see here, given angle is 90 minus alpha, right? So here this angle is 90 minus alpha. So side opposite to theta, that is angle, is called perpendicular. So AC is my perpendicular, but we don't want to find AC. Our aim is to find this, isn't it? This is my y-intercept. Okay, so this is my 90 degree. So side opposite to 90 degrees, hypotenuse. That means this acts like your base, right? So let's use again base and hypotenuse because we want to find the hypotenuse, isn't it? So again base by hypotenuse is cos theta, and what is theta here? Theta is 90 minus alpha. So we have cos 90 minus alpha is equals to, okay, so cos 90 minus alpha is equals to, that is cos theta is equals to base by hypotenuse. So what is base for me? Base is again OC, that is P, right? So P by hypotenuse is what? OA, isn't it? Now what is cos 90 minus theta? Cos 90 minus theta is sin theta. So we have sin theta here. So instead of theta we need to write alpha is equals to P by OA. So basically from here what is OA? OA is turning out to be P by sin alpha. Okay, so basically my y-intercept is equals to P by sin alpha. Okay, so we have y-intercept P by sin alpha. Fine. Now let us go to intercept form. Now in order to find the equation of this blue line, we have both x-intercept, we have y-intercept. Let's make use of this particular equation. So therefore we have x by a, and what is a? A is x-intercept, right? This a stands for x-intercept, which is P by cos alpha. Okay, so this is P by cos alpha plus y by, okay, y by we have b, that is y-intercept, which is P by sin alpha, and this is equals to how much? This is equals to 1. Let us simplify this. So we have this cos alpha goes up, right? This sin alpha also goes up. So we have x cos alpha by p plus this sin alpha goes up. So we have sin p, y sin alpha by p equals to 1. Yes? Okay, so if you multiply both sides by p, then this p and this p comes out here, right? So p and p gets cancelled, so only x cos alpha will be left plus y, again this 2 gets cancelled, so y sin alpha will be left equals to 1 into p is p. So this is your equation of line in normal form. Alright, so you need not write down full derivation of the equation, you just need to understand how the equation has arrived. What are the meaning of alpha and what is the meaning of p as well. That's what you need to understand here. Okay, so having understood normal form, now let us move on to the last form, that is symmetrical form, which is quite rarely used. You will see such kind of equation, or you will use such kind of equation most probably during your competitive exams. Okay, so this is called symmetrical, or this is called distance form as well. Okay, so let us see what is the meaning of distance or symmetrical form. So let me take x-axis and y-axis. So in order to understand symmetrical or distance form, here I am going to take one random straight line, okay, and let me assume that this line is making angle theta with the positive direction of x-axis. Okay, so here this theta means the same. Okay, and here I am taking one point through which this blue line passes. So this point, and let me call this as point x1 y1. Okay, and let me name it as point P. Okay, so here x1 and y1 stands for the same. Okay, and here let me choose one random point A whose coordinate is x comma y. So basically this x and y stands, this x and y stands for the same. Fine. Now We have used x, x1, theta, right? Similarly y, y1 and theta, but we have not seen what is this r. So this r basically stands for this distance, that is the distance between A and P. So as I said, this type of equation you will be using most often in your competitive exams. So we need to go through the detailed analysis of how this equation has arrived. So if you want to see how this has arrived, it's already given in your book, so you can have a look at that. All right. So with this, we close for the day. That is, we have seen various forms of equation of a line. Okay. In the next session, we are going to see the problems based on various forms of equation of a line. Thank you very much.